Very good morning, students. Welcome to our mathematics class. Number system part 6 video, Surds continuation. Today in this video we are going to discuss the operations on surds. First we see additions and subtractions of surds. Let us see, children. Addition and subtraction of surds is possible only if they are like surds or similar surds. That means if the given surds are similar surds, then only you can add or subtract. For example, root 2 plus 3 root 2 plus 5 root 2. Yes, these are all similar surds. These are all like surds. We can add them. The result is 1 root 2 plus 3 root 2 plus 5 root 2, 9 root 2. One more example. 2 root 6 plus 4 root 6 gives 6 root 6. 4 root 2 plus 3 root 2 minus 10 root 2. You see, children, 4 plus 3 is 7. 7 minus 10 is minus 3. So minus 3 root 2. In this way, we can add or subtract the similar surds, nothing but like surds. For example, 2 root 3 plus root 2, you cannot add. Root 5 minus root 3, you cannot subtract. They remain like that only because they are not like surds. They are not similar surds. So addition and subtraction is not possible. Let us see one example, children. Cube root 48 plus cube root 162. Cube root, this 48, you do the prime factorization, you will get 2 power 4 into 3 plus cube root. This 162, again you do the prime factorization, you will get 3 power 4 into 2. Next, this cube root 2 cube into 6, you expand cube root 2 cube into cube root 6. This you can write as cube root 3 cube into cube root 6. Cube root and cube gets cancelled, 2 into cube root 6. Here also cube root and cube gets cancelled, 3 cube root 6. See, 2 into cube root 6, 3 into cube root 6. These both are similar surds, like surds. So we can add. So 2 into cube root 6, 3 into cube root 6, totally 5 into cube root 6. Let us do one more example. Square root 98 minus root 18. The square root 98 you write as 7 square into 2 minus root 18 as 3 square into 2 by doing prime factorization. This root 7 square into root 2 minus this also root 3 square into root 2. Here the square root and square gets cancelled, 7 root 2 minus here also square root and square gets cancelled, 3 root 2. So both are similar surds now. So 7 root 2 minus 3 root 2, you can write 4 root 2. Now we see the next operations on surds, multiplication and division of surds. Let us see what the rule for multiplications and divisions of surds. Multiplication and division of surds is possible if they are of the same order. That means if the given surds are with the same order, then only we can multiply and divide. If not, then convert the given surds into same order and proceed. For example, root 3 into root 2, yes, both are quadratic surds, second ordered surds. Their order is same, 2. Then simply you multiply root of 3 2s, that's 6 root 6. You see the division. Square root 12 divided by root 2. Both are same orders with 2. So simply you can write square root 12 by 2. 12 by 2 is nothing but 2 6. So that equal to root 6. One more example. Suppose if it is asked to find root 3 into cube root 2. We need to multiply these two, but their order is not same. This is square root, 2 is the order, this is 3 is the order. So what I told you, we have to make their orders equal. For that, you convert this both into exponential form. Root 3 can be written as 3 power half into cube root 2 can be written as 2 power 1 by 3. Orders are nothing but these denominators 2 and 3. So take their LCM. The LCM of 2 and 3 is equal to 6. You try to get in this place of denominators 6. For that, in the place of 2 to get 6, you multiply numerator and denominator by 3, so it becomes 3 to the power of 1 into 3 by 2 into 3. Here also, in the place of 3, we need to get 6, so in the place of numerator and denominator, multiply by 2, so 1 into 2 by 3 into 2. Then it becomes 3 to the power of 3 by 6 into 2 to the power of 2 by 6. Now, we got the denominators same. Now, you convert them into radical form, I mean Surds form. Then 6th root 3 cube into 6th root 2 square. Now their orders is same, so you can directly multiply them. 6th root 3 cube is 27, 6th root 2 square is 4. So overall a single 6th root you can write 27 into 4, nothing but 6th root 108. Now the very important topic is rationalization. What the rationalization means, the process of converting a surd to a rational number by multiplying with a suitable surd is called rationalization of the surd. That means, to say in an easy way, eliminating the roots, whatever it might be, eliminating the roots. Next, rationalizing factor, simply we write as RF. What is a rationalizing factor? If the product of two surds is rational, then the two surds are called rationalizing factor of each other. For example, you take two surds, root 2 and root 2. If you multiply them, you will get 2, which is a rational number. So, root 2 is the rationalizing factor of itself. In the same way, you take root 3. Root 3 into root 3. If you multiply root 3 into root 3, you will get 3, which is a rational number. So, root 3 is the rationalizing factor of itself. One more example, children. Cube root 9 into cube root 3. Yes, both are having cube roots now. So, cube root 9 3s are 27. Cube root 27 you can write as 3 cube. Cube root and cube gets cancelled. The final answer is 3, which is a rational number. So, by multiplying these two surds, you are getting a rational number. That's why this cube root 3 is the rationalizing factor of cube root 9 and vice versa. That means this cube root 9 is the rationalizing factor of cube root 3. Some note points we have to observe here, children. The rationalizing factor of a given surd is not unique. Let me explain you in detail. For example, you take root 2. I told you root 2 rationalizing factor is root 2. Because root 2 into root 2 is equal to 2, we are getting a rational number. In the same way, for root 2, you multiply with 2 root 2, then you will get root 2 into root 2, 2 2's are 4. Here also a rational number. So product of two surds, we are getting a rational number. So obviously for root 2, 2 root 2 is a rationalizing factor. In the same way for root 2, if you multiply with 3 root 2, again you will get 6, which is a rational number. In this case also 3 root 2 is the rationalizing factor of root 2. If you continue this process, you will get many rationalizing factors of root 2. That's why I told you the rationalizing factor of a given surd is not unique, but always we take the rationalizing factor of a given surd in simplest form. The simplest rationalizing factor we consider. For suppose for root 2, the root 2 is the simplest rationalizing factor. It is very convenient to do us. Next, if one rationalizing factor of a surd is known, then the product of this factor by a non-zero rational number is also a rationalizing factor of the given surd. Just now I explained to you the way. It is convenient to use the simplest of all rationalizing factors of the given surd. This point also I explained you. Let us do some examples. Find the simplest rationalizing factor of root 75. The given surd is root 75. First of all, you convert into its simplest form. Root of 25 into 3. root 25 into 3. Root 25 is 5 root 3. In this 5 root 3, what is the third part? Root 3. So what is the rationalizing factor of root 3? Root 3. So for root 75 also, rationalizing factor is root 3. Root 3 is the simplest rationalizing factor. You also can check, if you multiply this both, you will get a rational number. One more example. Find the simplest rationalizing factor of cube root 36. Let us see this. Cube root 36 is equal to cube root 6 square. For cube root 6 square, the rationalizing factor is cube root 6 square is there, no? So we have to say 6, because if you multiply cube root 6 square into cube root 6, you will get cube root 6 cube, that equals to 6, which is a rational number. One more example, children. Rationalize the denominator in 2 by 3 root 3. I told you rationalization means eliminating the roots. In the place of denominator we have root 3, no? That should be eliminated. We rationalize with its rationalizing factor. So in the denominator's place, the third part is root 3. So what is the rationalizing factor of root 3? Root 3 only. So multiply numerator and denominator by root 3. Take the problem, 2 by 3 root 3 into root 3 by root 3. 2 into root 3, 2 root 3. 3 root 3 into root 3. Root 3 into root 3, 3. That 3 into 3, 9. See, the denominator is rationalized. That means there are no roots. In the same way, sometimes they can be asked to do the rationalization for numerator also. The same method we apply. One more problem, children. It is given that root 10 is equal to 3.162. It is approximate value. Then they are asking to find the value of 1 by root 10. This problem also I will solve by using rationalizing concept. So take that 1 by root 10. If you substitute the root 10 value directly, it's very difficult for us. So what to do is rationalize here. What is the rationalizing factor of root 10? Root 10 is in its simplest form, so its rationalizing factor is root 10 only. So you multiply this numerator and denominator by root 10. That means 1 by root 10 into root 10 by root 10. Then 1 into root 10 by root 10 into root 10, 10. Now you can substitute the value of root 10. What is given? That is 3.162 by 10. Children, you know 3.162 by 10 is nothing but what? 0.3162. Now we see rationalizing factors of different surds. Rationalizing factor of a monomial surd nth root a power m is nth root a power n minus m, because you multiply these two, you will get a rational number, nothing but without roots. Roots will be eliminated. Multiply these two. As their order is same, no? So you can take nth root of multiply these two radicands, a power m into a power n minus m. A power, these both can be added. You know that m plus n minus m. This both gets cancelled, a to the power of n. Nth root to power n gets cancelled, which is equal to a, which is a rational number. So their product is equal to a rational number. So obviously for this rationalizing factor is nth root a power n minus m. And also you see here two binomial surds. For this type of binomial surd, which is in the form of root a plus root b, rationalizing factor is root a minus root b, and vice versa. That means for this type of binomial surds, rationalizing factor is root a plus root b, because if you multiply these both, you will get a rational number. Roots will be eliminated. Check here. These both are in the form of a plus b into a minus b, no? So a square root a whole square minus b square root b whole square. Root a whole square is nothing but a, root b whole square is nothing but b, a minus b. So in this type of surds, If you want to write the rationalizing factor, simply you change the sign. If it is given with plus, you write with minus. If it is given with minus, you write with plus. For example, the rationalizing factor of root 2 plus root 3 is what? Root 2 minus root 3. For example, rationalizing factor of root 5 minus root 2 is what? Root 5 plus root 2, and so on. Children, the next concept is conjugate of the surd or conjugate surds. Let us see what the conjugate surds are. If the product as well as the sum, see children, if the product as well as the sum of two surds is rational, then the two surds are called conjugates of each other. That means you consider two surds, a plus root b and a minus root b. If you find out their product, a plus root b into a minus root b is equal to a square minus b, and also you find out their sum, a plus root b plus a minus root b, this both gets cancelled, 2a. These both are without roots, nothing but rational. So we can say a plus root b is a conjugate to a minus root b and vice versa. That means a minus root b is conjugate to a plus root b. So please try to understand, children. The sum and product of two surds is rational, then the two surds are said to be conjugate to each other. For example, if I ask you what is the conjugate of 2 plus root 3, we can say what? 2 minus root 3. What is the conjugate of root 5 plus 2? Immediately we can say root 5 minus 2. Let us solve one problem, children. The problem is rationalize the denominator 1 by root 7 minus root 6. Here we need to do the rationalization for denominator. That means we have to eliminate the roots in the denominator. So what is the rationalizing factor of root 7 minus root 6? Root 7 plus root 6. I told you, just change the symbol. Now you multiply this fraction with root 7 plus root 6 to the numerator and denominator. Then it becomes 1 by root 7 minus root 6 into root 7 plus root 6 by root 7 plus root 6. That equals to 1 into this, you will get root 7 plus root 6 only. Next, if you multiply these two, a minus b into a plus b, nothing but a square minus b square, root 7 square minus root 6 square. These both gets cancelled, these both gets cancelled. So it is root 7 plus root 6 by 7 minus 6, which is nothing but root 7 plus root 6 by 1, that equals to root 7 plus root 6. See, the denominator is 1. It is rationalized. The roots are eliminated. So in this way, we can do the rationalization problems. Children, by using all these concepts and some examples what I told you, you can do the problems in your textbook.